Now we'll start practice set 6.1. Question number 6. Prove that second one. Cos square theta in bracket 1 plus tan square theta. Second one. Cos square theta in bracket 1 plus tan square theta. Now we will write this cos square theta as it is. Here, what we get? 1 plus tan square theta. What is the identity? 1 plus tan square theta is equal to sec square theta. This is the identity we have to put here. Okay, we will put here sec square theta. Now, cos square theta into sec square theta. But we know sec square theta is equal to 1 upon cos square theta. 1 upon cos square theta. Then cos square theta into 1 upon cos square theta. This cos square theta will be cancelled, or we can divide them and we will get the answer 1. Okay, so here we can write cos square theta in bracket 1 plus tan square theta is equal to 1. Now see third problem. That is a square root 1 minus sin theta upon 1 plus sin theta is equal to sec theta minus tan theta. Now here we have to do the rationalization process, which is that rationalization. So when we have to do the rationalization, that time just we have to change the sign of denominator. Change the sign of denominator. So here you can write 1 minus sin theta upon 1 plus sin theta multiplied by 1 minus sin theta, which denominator this is, and we are going to change this positive sign into the minus 1 minus sin theta. Now we'll do this multiplication. What we get? 1 minus sin theta bracket square upon 1 minus sin square theta. Now here which rule is applied? For this we have applied that rule. For this 1 minus sin square theta, a minus b, a plus b is equal to a square minus b square. This rule we have applied here. Okay, 1 minus sin square theta. Now we will take its square root. What will take? Square roots of this. Now this is the squares are there. Okay, or you can write there first taking the squares. Taking squares. Okay, we have taken the squares. So what will get? This square root sign will go. While we are going to take here square, that time this square root sign will go. We will get 1 minus sin theta bracket square upon 1 minus sin square theta. We have taken here now squares. Okay, so here we know the one identity. This is cos square theta plus sin square theta is equal to 1. Then cos square theta is equal to 1 minus sin square theta. Got it? This identity we have to apply here. So we will write this identity now. Here we get 1 minus sin theta bracket square upon cos square theta. Got it? Then now we take the square root. What we take here? Square root. Write down here taking square roots. While we take the square root, then we get 1 minus sin theta upon cos theta. We got there 1 minus sin theta upon cos theta. So this cos theta is the denominator for both. Then we will write it separately. 1 upon cos theta minus sin theta upon cos theta. Sin theta upon cos theta. Now 1 upon cos theta we know it. What is it? Sec theta minus this will be your tan theta, and this is only your RHS. Understood? So you get LHS is equal to RHS. Problem number 4. Sec theta minus cos theta. In second bracket, if their multiplication sign is there, if two brackets are given, in between the two brackets their multiplication sign is there. So sec theta minus cos theta in second bracket, cot theta plus tan theta, and we have to show it their tan theta into sec theta. So now we should know the first their properties or identities. Sec theta. So sec theta is equal to 1 upon cos theta. Okay. Then cot theta is equal to cos theta upon sin theta. And we know tan theta is equal to sin theta upon cos theta. So these identities we have to apply here. Okay. So now first we'll see first one, that is just sec theta. Instead of that we write 1 upon cos theta minus cos theta. In second bracket, instead of cot theta we have to write cos theta plus sin theta and plus sin theta upon cos theta. Instead of tan theta we have written this. Now we got here. So here cos theta here denominator, here nothing is there, means always 1 is present. Nothing is means always 1 is present. When we have to subtract them, minimum their denominator should be there same. Okay, that is the requirement there. So we'll apply this side or we'll multiply this side by cos theta, only this side, remember. So 1 upon cos theta minus, here I am going to multiply by cos theta into cos theta upon cos theta. Okay. Second bracket multiplication as it. Now here cos theta upon sin theta, here sin theta upon cos theta. Again here we have to multiply this side by the cos theta and this side by the sin theta. Then only we will get the same denominator. Okay. So we will write cos theta into cos theta. You can write your multiplication side or like the dot also you can give. Sin theta into cos theta plus sin theta into sin theta upon sin cos theta into sin theta. Okay, like this. Now 1 upon cos theta as it is minus cos square theta. See, cos theta into cos theta is cos square theta upon cos theta. Got this first bracket? Then second bracket, cos theta into cos theta, here we will get cos square theta plus sin theta into sin theta, sin square theta. Okay, its denominator is there same. So I will write here directly sin square theta upon sin theta into cos theta. Got these two brackets? Now 1 minus cos square theta. This also we can write directly, or we can write this cos theta as it is. So 1 only, instead of 2 we will write at once. So 1 minus cos square theta, already we know the some identities, which are that sin square theta is equal to 1 minus cos square theta. By our this identity, sin square theta plus cos square theta is equal to 1. Okay, this identity we have to apply here. Then this cos square theta plus sin square theta also that we can apply here. Now we can write 1 minus cos square theta, it is sin square theta upon cos theta. Got it? Sin square theta upon cos theta in this bracket. In this bracket we will write cos square theta plus sin square theta, that is the 1. What is it? 1. This is our identity, sin square theta plus cos square theta is equal to 1 upon we will get sin theta into cos theta. Okay. Now we will take them out of bracket for the multiplication next thing. Okay. So now here sin square theta upon cos theta multiplied by 1 upon sin theta into cos theta. Sin theta into cos theta, it remains as it is. Okay. This sin square and cos square will return 1. Now here sin square theta means what? Sin theta into sin theta. Sin square theta means what here? Sin theta into sin theta. So we'll divide this. Sin theta into sin theta, here remain only sin theta. Okay, so we'll get sin theta upon cos theta into 1 upon cos theta is equal to sin theta upon cos theta is there. We know it's there tan theta. And this 1 upon cos means sec theta. Did you got like this? See your RHS. Okay. So here first you should remember identities. Then only you can solve this problem. Okay. Now we see the problem number 5. Cot theta plus tan theta is equal to cosec theta into sec theta. Now here we have to apply the identities. Cot theta is equal to what we will get? Cos theta upon sin theta, and tan theta is equal to sin theta upon cos theta. These two identities we have to apply here. We are going to use here. So now cos theta upon sin theta plus tan theta. Sorry, instead of tan theta, what we are going to apply here now? Sin theta upon cos theta. Now, if you see this cos theta upon sin theta plus sin theta upon cos theta, we have to add it. Then we have to do the multiplication both sides. Okay, cross multiplication by this cos theta and this side. Okay, so we will take cos theta multiplied by here cos theta upon sin theta into cos theta plus here we have to multiply by sin theta into sin theta upon sin theta into cos theta. Okay, cross multiplication we have done here. Now cos theta into cos theta, cos square theta plus sin into sin, sin square theta upon sin theta into cos theta. Okay, now we know the next identity, that is sin square theta plus cos square theta is equal to 1. So 1 upon what we get now? Sin theta into cos theta. So write this separately, is equal to 1 upon sin theta into 1 upon cos theta. Now 1 upon sin theta we know it's cosec theta, and 1 upon cos we know it's their sec theta. We got LHS is equal to RHS. So like this you can solve the problems.